Hi kids, welcome back to Common Core Algebra II. Today's lesson 8.4 is the quadratic formula. Now this isn't really new. We've talked about the quadratic formula before in Algebra 1, and the beautiful thing is the quadratic formula is given to you on your reference sheet in case you forget it during the Regents exam. So the activator, actually we're going to save that for in place of our quick poll tomorrow. So if you want to do it now and get a head start, you can do it now, but I'm going to give you time tomorrow in class, about 5 minutes to get these done. Okay, so again, I'm going to move on from the activator, hold that till tomorrow, and I'm going to start here at exercise 1. So we're going to consider the quadratic function f of x, and A says algebraically determine this function's x-intercepts using the quadratic formula. Now again, x-intercepts, another way to call x-intercepts would be zeros, solutions, roots, all right? And express your answers in simple radical form and express your answers to the nearest hundredth. So the first thing I always do is I write down the quadratic formula because it helps me remember it. So I know x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. All right, now just to remind ourselves what a, b, and c are, we're going to get them from right here in our quadratic expression, our quadratic function. So a is going to be the coefficient in front of my quadratic term, which is simply 1. B is my coefficient that's in front of my linear term, which is negative 4. And C is my constant right here, which is negative 36. So we're just going to substitute in now. All right, so we have x equals the opposite of b, so it's going to be positive 4 plus and minus the square root. Now b squared, whenever you square, whether it's positive or negative, it'll always become positive. But you can do negative 4 squared, just beware, make sure it's in parentheses, minus 4 times a times c, and that's all underneath that radical. And then the whole thing is divided by 2 times a, in this case a is 1. And from this point, we're just going to simplify. I think the easiest thing to do is I start with my discriminant. X equals 4 plus or minus. Now, the discriminant is what's underneath this radical. So I put this whole thing into my calculator just the way it looks, and I get 160 divided by 2. So now 160, I'm going to, it says simplest radical form, so I'm going to have to do some thinking about this. So I'm going to come over to the side here and do the square root of 160. I'm going to remind you, we're going to pull it into a perfect square and the leftover. So the perfect square would obviously be 16 times 10, which is 4 square root of 10. So I can come back here and I get x is equal to 4 plus or minus 4 square roots of 10 divided by 2. And then one more time now I can do some simplifying here, because remember, when you have divided by 2, that's like having this one divided by 2 and this one divided by 2. So I can say x is equal to 2 plus or minus 2 square root of 10. Now remember what that means. That means I have 2 plus 2 square roots of 10, and I have, so x is equal to that and 2 minus 2 square roots of 10. We actually get 2 answers. All right? So in that case, that's our simplest radical form. And then they also ask us to find it to the nearest hundredth. So this one is going to be 2 plus 2 square roots of 10 is 8.32 approximately, and also negative 4.32. That's our answers to the nearest hundredth. Okay. So nothing really new here, just manipulating those radicals, which makes things a little bit difficult, but it's not too bad. So write down what you need to, rewind if you need to, and I will meet you at exercise 2. Okay, so which of the following sets represents the x-intercepts of y equals 3x squared minus 19x plus 6? So there's a couple of different ways that we can do this. You can do this on your calculator, but because our answers are in radical form, I mean, you could give it a quick check in your calculator to see if one of these is your answer. And if you checked with number 4, you would find out that was the right answer. But I think how they really want us to do this is using the quadratic formula. So once again, I'm going to say x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. And I get that off my reference sheet. All right, so x is equal to, remember, a is 3, b is negative 19, c is 6. All right, so x is equal to negative b, which is positive 19, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So we do some more moving around here, and we get 19 plus or minus, this one comes out to be nice, 289 divided by 6. Remember what this means. This is the same thing as 19 plus or minus 17 divided by 6. So we have 19 minus 17 over 6, and we have 19 plus 17 over 6, which turns out to be 1/3 and 6. So our answer turns out to be number 4 right here. Okay, we're moving on to exercise 3 right now. So we're revisiting the Crazy Caramel Corn Company. All right. Recall that the Crazy Caramel Corn Company modeled the percent of popcorn kernels that would pop P as a function of the oil temperature T in degrees Fahrenheit using the equation blah. All right. So using this equation. So the company would like to find the range of temperatures that ensures that at least 50% of the kernels will pop. And remember, our P represents percent. All right, so write an inequality whose result is the temperature range the company would like to find. Solve this inequality with the help of the quadratic formula. So basically what they're saying is they want you to take the negative 1 over 250 t squared plus 2.8 t minus 394 has to be greater than or equal to 50, because remember, P represents the percent. All right. Now, whenever I'm dealing with whenever I'm dealing with quadratics and I'm dealing with inequalities, I always want to make sure my leading coefficient is positive. So the first thing I'm going to do is I'm going to multiply through by a negative. And when I do that, I get 1 over 250 t squared minus 2.8 t plus 394 is less than or equal to negative 50. All right, so the first thing we have to do, we should always know when we're solving for quadratic, we have to have it equal to 0. So basically what that means is I'm going to add 50 to both sides, and I'm going to get 1 over 250 t squared minus 2.8 t plus 444 is less than or equal to 0. All right, now we can finally start working on our quadratic formula to find out what our interval is going to look like. So A is equal to this. Here's A, here's B, here's C. So x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Now, if you don't like to write that 1 over 250, you can replace that with 2 times 0.004. Some people don't like to deal with fractions. I'm actually one of them. So when I put this whole thing into my calculator, the first thing I'm always going to do is my discriminant. So 2.8 plus or minus the square root, and this comes out to be 0.736 divided by 0.008. All right, so I'm going to put this into my calculator now because remember I'm going to have 2.8 plus the square root of 0.736 divided by 0.008. And you know what? This is my lower bound. So if it's okay with you, I think I'm going to make this one, oh, that wasn't supposed to happen. I'm going to make this one 2.8 minus the square root of 0.736 over 0.008. This is my upper bound, so it's going to be 0.8 plus the square root of 0.376 all over 0.008, which turns out to be 40, turns out to be, if I can read my writing, 457.238. Nope, I'm reading it backwards. 424,762. This one is 457,238. And because it's telling us to the nearest tenth of a degree, we know it's less than. We know it's going to be an interval where x is sandwiched between the two numbers. So x is going to be sandwiched between 424.8 and 457.2. And remember, actually, it's not x, it's t. I have to go back to this too once in a while. Even though we said x equals, it's really t with less thans between it. Can it equal 50? At least 50. It can equal 50. Did I put an equal sign in there? I did. Good. Just wanted to make sure. So this is my answer. And I knew it was an interval because it turned out to be a less than. All right. If not, you can pick numbers on your number line and give it a check. Great question. Not that hard, but kind of gives you the impression it's a hard one. Now, we only have one more question to consider in exercise 4. So when you're done with this one, I'll meet you there. Okay, so exercise 4 says find the intersection points of the linear quadratic system shown below algebraically. Then use your calculator to help produce a sketch of the system. Label the intersection points you found on your graph. All right, so if we're doing this algebraically, we have to make sure that we are recognizing how to solve the systems. Now, so one way is to use substitution. Another way is to just set them equal to each other, which is still a way of using substitution. Because I have y is equal to this, and I have y is equal to this, I can simply set these equal to each other. Minus 6x plus 2 is equal to 6x minus 3. Now remember, when you're looking for a system of equations, you're looking for, now this is a quadratic with a linear. So if they're asking you for a parabola with a line, I'm going to remind you that we have a couple of different situations here. We could have two solutions or 2 points of intersection like that. You could have 1 point, if I can get this to move, you could have 1 point of intersection like that, or there is a possibility your line doesn't even hit your parabola, and there's a possibility of not having any solutions. So let's see what we're going to end up with this one. So remember, when we solve a quadratic, we're going to make sure that we set it equal to 0. So I'm going to move this over, and I'm going to move this over to the other side. Minus 6x plus 3, and I get 4x squared minus 12x. Be careful there. People make that mistake pretty often, thinking it's 0, plus 5 equals 0. All right. So now let's take a look and see what we have. So here's A. A is 4, B is negative 12, C is 5. So x is equal to, it is x this time, yep it is. X is equal to the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to come here one more time and do that discriminant. So I get 12 plus and minus. This whole discriminant turns out to be the square root of 64. Very nice. All over 8. So what does that mean? It means I have 12 minus 8 over 8. And I have 12 plus 8 over 8. Because remember, the square root of 64 is 8. So 12 minus 8 is going to be 4, and which reduces to 1/2. And 12 plus 8 is 20, divided by 8 reduces to 5/2. All right, so now this is showing me that I'm going to have two solutions. But remember, your solutions are points. So the point that I'm making is we have two x values. Our two x values are going to be 1/2 comma something, and then 5/2 comma something. So we need to find those y values. So we're going to go back and we're going to pick that. I'm going to just slide up here for a second. We're going to pick the easiest one right here. I'm going to pick the linear function, y equals 6x minus 3. I'm going to come back down here and say y is equal to 6x minus 3. And I'm going to substitute these points in. I'm going to do y is equal to 6 times 1/2 minus 3, which is 3 minus 3, which is equal to 0. So when x is 1/2, y is 0. And the other one is going to be y equals 6 times 5/2 minus 3. And we put that in my calculator, and I come out with 12. So there are my 2 points of intersection. 1/2 comma 0 and 5/2 comma 12. Now I'm hoping you realize there's a way to check this in your calculator using your intersection. Put both your functions in and use your intersection command to find out what those numbers are. All right, that's very easy to do. But remember, if it says algebraically, you have to make sure you're showing your work. So according to this one, our 2 points of intersection are 5/2 12, which is 2.5 12. So here's 5. Here's 2.5. Here's 12. There's 1 point of intersection. And the other is 1/2 comma 0. So maybe somewhere around here. So remember, this is going to be the line going between. This is a very, very rough sketch, so my apologies. All right, and I know that the parabola has to go through these 2 points, so I know the parabola is going to look something like that. All right, so here are the 2 points of intersection. It says to label them, so we can label this one is 5/2 comma 12. This one is 1/2 comma 0. All right. If they asked you to graph it, they would give you a much nicer graph with grid lines and everything. Okay. So that's it for today. Try to keep it under 20 minutes, which I did. And tomorrow in class, we will work on 8.4 classwork, which is going to also talk a lot about using this quadratic formula. So I think the hardest part about doing this is just simplifying the numbers, simplifying the radicals. I think you got complete use of the quadratic formula. I think you won't have a problem, finishing these problems tomorrow. So until then, make good choices as always, and I'll see you then. Bye-bye now.